Hi everybody, my name is Olivier Klein and I'm a solutions architect with AWS focusing on emerging technologies. Today I want to talk about how AWS and specifically AWS IoT can be used to build smart devices. So what is the Internet of Things, or IoT in short, really about? It allows us to build products that slowly get smarter over time as we are able to sense the physical world and fine-tune products to end customers' needs. As a result of having better ways of continuously measuring and interacting with the physical world, we can also use this to make any processes more efficient and predictable. And then in effect, this will also drive a closer relationship with our end customer and maybe even allow us to produce new product offerings that weren't even possible before. Today we will focus on AWS IoT. AWS IoT allows you to securely connect billions of devices to AWS so that they can interact with applications and other devices. Let's zoom into the details of this service. AWS IoT is comprised of different elements. The device gateway that allows you to connect devices securely in an authenticated and authorized manner. The ability to register devices and have those talk to AWS IoT using our device SDKs. The rules engine to transform any message based on rules and route them to other devices, AWS services, or even third-party services. And lastly, the device shadow, which allows you to persist think state during intermittent connectivity. The device gateway uses standard protocols to talk to the devices. You can choose from MQTT, an extremely lightweight protocol which works well on lower bandwidth connectivities, HTTP, or WebSockets. The device gateway is designed as highly scalable pub/sub broker so that you can subscribe to various topics and publish messages to others. The topics can be freely defined, such as the one example given on the left with things/thing2/color. Lastly, any communication between the device and the device gateway will be authenticated and secured using an X509 certificate and TLS 1.2 mutual authentication. As messages are coming in through the device gateway, they can be manipulated and rerouted using the rules engine. The rules engine uses a SQL-like syntax to select messages from topics and filter them before defining the rule action. This syntax also allows for more specific selects with advanced JSON support or mathematical functions. Let's have a closer look at the syntax. The idea is that you select certain data from any of the topics and filter out only certain messages. The select statement can select all data fields in a message payload or only select certain properties, such as, for example, only picking out device ID or temperature, or even return an MD5 hash of the device ID. Where are we selecting this data from? Well, from the topics that we send messages to. The from statement helps us to select messages from certain topics. It also allows for wildcards in between to provide flexibility around querying multiple topics at the same time. So it's just like scanning a database table, but with wildcards. Lastly, when it comes to filtering, we can use the usual kind of tokens to filter out messages with certain properties. Logical operators, parentheses, arithmetic, or mathematical comparators are available. Lastly, as we define these rules, we can select which actions we want to take. We can forward these filtered messages to other devices, send it to our Amazon S3 storage service, or have it evaluated by an AWS Lambda function, or maybe just forward it to our simple notification service. Oh, and by the way, you can define as many rules as you wish, and they are always evaluated and processed simultaneously, no matter how many you have. Another great element of AWS IoT is the thing shadow. The thing shadow is a virtual state representation in the AWS cloud environment. This is useful when you have devices that might have intermittent connectivity. Devices can report their state to the thing shadow, and other applications can read or manipulate this state in a cloud environment. If the device goes offline, other applications can still modify the state of a device. And then when the device comes back online, it will synchronize with the thing shadow. To get you started quickly with connecting a device to AWS IoT, we also offer various AWS IoT device SDKs. We have an embedded C SDK available, which is great for chips that have an embedded OS or are heavily resource constrained. If you have devices that come with embedded Linux platforms, then you might be happier with the C++, JavaScript, Java, or Python SDK. If you own an Arduino Yun, we also have a device SDK specifically for it. And lastly, for mobile devices or tablets, you can use the mobile SDKs. All right, let's try to see this in action. Let's use an Intel Edison with the Arduino breakout board and have some sensors and actuators connected to it. We then use AWS IoT to read some of those sensor information and interact with the buzzer, the server, and LCD screen attached to this board. All right, so what we've got now here is the Intel Edison with the Arduino breakout board. We're going to try to understand a little bit how we connect this to AWS IoT, look at some pieces of code, and play a little bit around with the console and see how we can interact with some of those sensors and actuators that are attached to it. So first, let's have a look at our AWS IoT console here. Here we see a dashboard, and you see that I already have some connections coming through. Now let's have a look how we would have this Intel Edison connected to AWS IoT. To do that, we're going to click here on Registry, and then under Things, we will see the different things that are connected to AWS IoT. And as you already see here, the Intel Edison has already been connected. Let's have a quick look at this. Now, after we create a thing in AWS IoT, it will provide us with this individual thing ARN name. It will also allow us to create a security certificate that we attach to this thing. Let's have a look at this. Here we see there's a certificate attached to the AWS IoT thing. If we click on this in more detail, it will provide us with the information of that certificate. Now, this certificate is important because this certificate, as we generate it, we will push it to the Intel Edison device, and this will hook up the Intel Edison device securely with the AWS IoT service, which will allow it to use the mutual authentication of TLS 1.2 and, of course, encrypt also the communication in between. Let's have a quick look on how we could load this up into our Intel Edison device. What you see here is one of the sample codes that I will run in just a bit on my Intel Edison device. As you can see in the first line, I will actually use the AWS IoT device SDK. This will make it very easy for us to connect this Intel Edison device with AWS IoT. Now, where do we connect it to AWS IoT? Well, it's as simple as one single line of code as you see here. AWS IoT.device, and we indicate the certificate that we just received earlier, and this will bind those things together. The next thing that we can then do is to listen and publish and subscribe onto certain topics. So as soon as we have successfully connected to AWS IoT, we will subscribe to a topic called Edison/commands. We will then also publish a message to Edison/messages and say, hey, our Edison just came online. Now let's try to put this in action. Let's first go back here to the AWS IoT console and click on the test element here in the menu. This will allow us to actually run an MQTT client here in my browser to listen onto certain topics and also send certain messages onto topics, which will allow me to debug what's going on my Edison device and also via my browser talk to this thing now. So the first thing that we're going to do is we're going to listen to every possible Edison/topic. We're going to subscribe to this. Now, if I'm going to now open an SSH connection to my Edison, which I have done here in my terminal, I can now run this demo code by saying node demo.js, which will then connect to AWS IoT and should subscribe and publish to these topics. And as we see, voila, here already the first message came through and says, hey, your Edison is online. Great. Now, as you see now, some of the LCD screen went online, and we slowly now get temperature reading that we sense here from this temperature sensor and display it, the humidity and the temperature on the screen itself. Now let's see how we can interact with this Edison device. I subscribe to an Edison/commands topic. Now, what if I send certain information to that Edison/commands topic? Now let me take this sample here, which is the JSON string I can send to send certain action to my Intel Edison device, and we're going to send that to Edison/commands. And let's start off with a beep. There's a buzzer attached here, and we want to understand if we can remotely make this buzzer beep. I click on Publish Topic, and there we go. Nearly immediately, the buzzer went off. We try this again. We immediately get the beep sound true. Now let's have some fun with that LCD screen over there, shall we? If I change this action message to LCD, and I say, hello, AWS as a message, and I publish this topic, we now see that we see hello, AWS on the screen. I can also go ahead and change the color of the screen and maybe make it red. Or how about green? Let's change this color to green, send the message through, and here we go. We changed it to green. Now we also have a little servo here, which could be interesting if we want to deploy certain Edison device and unlock or lock of a door, for example, or operate a certain machinery. Well, we have a little small servo here. Could we spin that and actuate it remotely from AWS IoT? Well, again, I could take here servo and set the angle of the servo to 180. Publish it to the topic, and we see our servo is spinning. Publish it back as an angle to 0, and our servo is spinning again. Now, if you want to build a smart home appliance at home, you might want to connect a light to an Intel Edison device. One easy way to do that would be via a relay switch. Now, what you see here is a small little relay that would allow me to cut off or put on a certain power cable that we push through it. So one thing that I could do is to say, I want to take this relay and put the state to off. Now the state is off now. How about switching that state to on? And if we have a close look at this now, we see that the relay clicked, it switched on, and current can now pass through and would switch on the light if we would have connected it to it. If I put the state back to off, our relay will switch off again. So we now have the ability to use AWS IoT to remotely control one or many or millions of those devices that are now connected to AWS IoT. So this would be talking to the device itself. Now, we also have certain information that this device is collecting, specifically the temperature reading here and the humidity. Now, can we send that back to AWS? This is a perfect example for something like the thing shadow. Now let's go back to our registry here and look at our Edison thing. If I look at my Edison thing, I will also find a value of shadow here. Let's click on shadow, and we now see that my Intel Edison is currently reporting back a certain temperature. Now that temperature is coming from this temperature sensor here. That reading is both displayed here on the LCD screen and as well sent back to the thing shadow, which is what we're seeing right here in the console. Now let's see if this is actually live, shall we? So I got a little lighter here. I'm going to hold this lighter against my temperature sensor. And if I hold this relatively close, we should see that the temperature will immediately spark up on both the display and, of course, also here in my AWS IoT Thing Shadow console. So now we demonstrated how we can effectively, with one line of code, connect an Intel Edison device to AWS IoT, remotely control it via our AWS IoT service by publishing certain messages through, and at the same time subscribing to certain messages to get information out of this device, out of this thing, back into the AWS IoT service, and then we can process it there. Next up, let's have a look at the device called Amazon Echo. Amazon Echo allows us to talk to the Alexa voice services whenever we are calling its wake word. The default wake word would be Alexa. So we can, for example, say, hello, Alexa, and she will respond to us. Now, the Alexa voice services are an open ecosystem where every developer can extend the capabilities of what Alexa can do. Let's have a look at that. The Alexa voice services can be extended by creating an Alexa skill. This Alexa skill will call your piece of code to respond to a user's request. This piece of code can run on your own web service or, alternatively, what we would recommend, in an AWS Lambda function. In this piece of code, you can call other systems to fulfill an intent and then return back a response to the user. Alternatively, you can even handle a continuous conversation with Alexa using your function code. All right, let's try this out. So here we got the Amazon Echo Dot, which is the smaller sister or brother of the Amazon Echo. Now let's see what we can do with this. Alexa, say hello.
Hello.
Alexa, how are you today?
I'm great. I hope you are too.
I am. Alexa, where are you right now?
I'm here and my head is in the cloud.
Awesome, which allows us to extend the ecosystem of what is possible here. For example, I can write a skill that would allow me to connect to my Intel Edison device earlier so that I can change the color of the Intel Edison device. Alexa, ask Edison to change color to red.
I changed Edison's color to red.
Now, since this is an open ecosystem, anyone can integrate their own skills against it and allow anyone to use those skills. So for example, Spotify integrates with it. Let's have a look at that. Alexa, play You Give Love a Bad Name from Spotify.
You Give Love a Bad Name by Bon Jovi from Spotify.
Alexa, stop. Okay. How about having a bit of fun with robots, shall we? You might have heard of a company called Sphero. They produce small toy robots, and one of them is called SPRK Plus. They also built a Star Wars specific version which was called BB-8 and became really popular. Now, this robot can be controlled via Bluetooth. Our Intel Edison board actually has a Bluetooth functionality. So what we can do is to connect our Sphero robot to the Intel Edison and have the Intel Edison connect to AWS IoT. This will allow us to remotely control our robot from our AWS cloud environment. In addition to that, let's create an Amazon Alexa skill so we can also use our voice to change our IoT thing shadow and as such have the ability to use our voice to change the color of the robot remotely. All right, let's try this. So here we got our Sphero robot, and now we're going to try to connect this Sphero robot via Bluetooth to my Intel Edison, and our Intel Edison will be connected to AWS IoT so that we can remotely control the robot, but also sense its environment and detect collisions. Now let's try this out. First, we're going to switch over to our AWS IoT console here. Now, let's again listen to the Sphero topics that we have. So I'm going to click here onto my MQTT client. Now I'm going to listen to a topic which I called Sphero, and I'm going to listen to both the action and commands by using this plus sign here. The next thing that I'm going to do is power up the little JavaScript that I run on the Intel Edison to connect the Edison with AWS IoT and also connect the Sphero via Bluetooth to the Edison. Let's try this out. Let's power it up. And now what the Intel Edison will do is it talks to the Sphero, activates it, and the light came on. Now it also connected to AWS IoT. So let's see if we can remotely control this. All right, let's keep rolling. And here we go. We start now sending messages, as you see on my screen, which are JSON messages that basically say that it's rolling. Now, as we're doing quick movement changes here, we also see slight collisions coming through. Now, let's try to simulate that a little bit better. How about having a little wall and now rolling our robot with a little bit more speed into this block. And here we go, and try this again, and we see a collision slowly coming through here. If we go back to our IoT dashboard here, we see that collisions are coming in after we roll through. So we now have the ability to not only remotely control our robot here, but we also have the ability to sense our environment. Now lastly, we also have a certain thing shadow set for our robot onto Intel Edison device. Now that shadow is specifically the color. So what we can do is use our voice together with Alexa to change the color of our Sphero robot. Let's try this. Alexa, ask Sphero to change color to green.
I changed Sphero's color to green.
Communicated that message to a Lambda function, talked to the Intel Edison, updated the thing shadow via AWS IoT, and communicated that message via Bluetooth. Let's try this one more time. Alexa, ask Sphero to change color to blue.
I changed Sphero's color to blue.
And here we go. We changed the color to blue. So what we've achieved now is we took an animate object here that we connected via Bluetooth and via AWS IoT to a cloud environment so we can remotely control it, sense our physical world, bring it back into our virtual world, and also control it using natural language processing. All right, I hope you enjoyed the demos, but remember, a full IoT product doesn't stop after connecting things to a cloud environment. But don't sweat it. AWS has all the necessary services to build highly available and scalable IoT solutions. May it be your storage or edge service requirement, companion apps and mobile devices or tablets, or any of your analytical or machine learning needs. So go and build. We would love to see your next interesting connected thing. Now, if after today you're wanting to take your AWS knowledge to the next level, you have several options available to you. To gain more confidence and hands-on experience with AWS, watch our instructional videos and explore the self-paced labs. Additionally, you can attend our instructor-led classes by qualified AWS instructors and learn how to design, deploy, and operate highly available, cost-effective, and secure applications on AWS. And finally, don't forget to validate your technical expertise with AWS and use practice exams to help you prepare for AWS certifications. Also, finally, I would like to thank you for attending this session today and sticking it out to the very end of the presentation. Please take the time to provide feedback on today's event so that we can improve the event experience for you in the future. Thank you very much for your attention.